Okay, hello, dear colleagues. So let's start our defense. So today we have the defense of the dissertation work of Kanzhigitova Dana. I'm sorry, I hear some echo. Okay. So the title of the dissertation is the development of novel functional hybrid materials based on conducting polymers. Submitted for the PhD degree on specialty on the educational program 8D05301 chemistry. The dissertation was performed at the Department of Chemistry and Technology of Organic Substances, Natural Compounds and Polymers of Al-Farabi Kazakh National University and the School of Engineering and Digital Sciences of Nazarbayev University. So the PhD student is here. So scientific supervisors are Rayhan Rahmetullayeva, PhD, Assistant Professor of the Department of Chemistry and Technology of Organic Substances, Natural Compounds and Polymers, Al-Farabi Kazakh National University, Almaty, Kazakhstan. Nurshat Nuradja, PhD, Associate Professor of School of Engineering and Natural Sciences, Nazarbayev University, Astana, Kazakhstan. And Matthias Ulbricht, PhD, Professor in University of Duisburg-Essen, Germany. So scientific supervisors, I think they are present. Okay, official reviewers. Let's start from temporary members. Temporary members of dissertation council are Rehab Khaleb Mahmoud, Professor, Doctor, Department of Chemistry, Beni Suef University, Egypt. So Professor Mahmoud, are you okay? Is present or not? Sadat Медвековна, Professor Mahmoud.
Ол кісі қатыса алмайды деді ғой.
Қалай?
Режимесі бар да?
Қалай?
I don't see. Rehab Khaleb Mahmoud, I don't see.
Кім қатыса алмайды, Райхан?
Зарубежный руководитель айтады.
Хорошо.
Временный член.
Временный член сұрап жатыр.
Professor Mahmoud, are you here? I see some hairy Megbenu. Who is that?
Hari is PhD student here, but I also don't see.
Это мужья, да?
Окей, Садат Мирбековна, вы не могли бы связаться тогда с профессором Махмуд?
Махмуд. Хорошо, сейчас буду писать ему.
I'm asking because all temporary members must be present. Okay, the second temporary member is Fahad Al-Hashmi Al-Amer, PhD professor, Al-Qura University, Saudi Arabia. Professor Al-Amer is present, I think. Sergey Filipov, PhD. Okay, thank you. Sergey Filipov, PhD, DWI Leibniz Institute of Interactive Materials, Aachen, Germany.
Yes, I'm here.
Okay. Thank you. And Sergey Dergunov, PhD, a doctor, research professor, University of Connecticut, United States of America. Okay.
Yes, I'm here.
Dr. Dergunov is here. Okay, official reviewers are Azad Said Khan, PhD, associate professor, director of the engineering laboratories at Bayev University, Almaty, Kazakhstan.
Good afternoon, I'm here.
I see, thank you. And Khaisa Avchukir, PhD, senior lecturer, Department of Analytical Colloid Chemistry and the Technology of Rare Elements, Al-Farabi Kazakh National University, Almaty, Kazakhstan. Okay, Dr. Avchukir, I saw him.
Salamat.
Okay, thank you. Okay, I think we need to wait for Professor Mahmoud. So just a couple of minutes, we will try to connect. Maybe there is some problem with connection. I'm sorry. Dear colleagues, I'm sorry, but we are trying to reach the temporary member, but we need to wait. I think we should wait 5 more minutes, and then if not, then we will have to postpone the defense. I'm sorry, but such issues happen from time to time. If not, we will have to appoint another member.
So Boatolo, it's mandatory to join temporary members.
Yes, all must be present.
Влад Нурланович,
Да-да.
this is his problem, not others. It is depending on the.
Yeah, maybe something happened, so I don't know. We just don't get any response, and probably in a couple of minutes, if not, then we will have to postpone the defense.
Without him, how about? Because other professors, other temporary members also
No,
need to.
we cannot.
Oh, okay.
We cannot replace.
Because he's agreed, right?
Unfortunately, no response, and we cannot reach the temporary member. So, dear colleagues, probably it's already 20 minutes, and unfortunately, we must make a decision to postpone the defense for the later time. And we will try to reach the temporary member. If not, if there is no response, we will have to replace the temporary member and appoint another date with a new temporary member. Unfortunately, such cases happen, so anything can happen with people. So I don't know, maybe technical problems, or I don't know what happened. Because we sent we received the confirmation that the temporary member agrees that if she is not present, then the defense is cancelled. So the temporary member knows that she must be present during the defense, but she is not here.
Okay, so which day you want to appoint next?
I'm sorry? Can you repeat?
Which day you want to appoint the defense with
Which
new
day?
members? Yeah.
Yeah, but we will have to decide it with the other members. So it's maybe tomorrow or today, later today, we will decide.
Okay.
Okay, dear colleagues, do you have questions? I see that there is a message in the chat to send the name. So the name, just a second, I will send the name. Of the temporary member. This is Rehab Khaled Mahmoud from Egypt. Unfortunately, we don't have the phone number. We only have 2 emails. Okay, dear colleagues, so I have to announce that the defense is postponed because one of the temporary members is not present at the defense. Yeah, and we will make official announcement and let you know about the new date of the defense. Most probably it will be next Tuesday, because there is no other possibility.
Болат Нурланович, we
have to
have a
negotiate it.
conference. Болат Нурланович, we have a conference start from 24th of June. So next week, Professor Nuraja and Raihan also now available.
Oh, okay. So we will have to negotiate it, but our defense is the last day of work of our defense is 28th of June. Yeah, so after this date,
Oh.
the new dissertation council will be formed. Okay, but okay, now I will not say anything about that, so we will have to discuss it with the administration also. Okay, dear colleagues, I'm sorry that this case happened. Yeah, and see you at the postponed defense next week or maybe later. Okay. Okay.
Sorry, next week I have the business trip in Poland, so for me it's impossible for next week. Sorry.
Okay, we will negotiate another date.
Yeah.
Okay.
Yeah.
Okay. But no, not
So.
now, because it will take some time.
Yes. Thank you. Understood. Yeah.
Okay, thank you, and I'm sorry again for this case. Bye.
Can you give more 10 minutes? I'll try to contact with my friend in Egypt to try to contact with Professor
Okay, yes.
Khalid. Just more
Yes.
5 or 10 minutes.
Okay, if you can, yes, please.
Just give
Good
us.
idea.
Just
Okay.
give me 10 minutes.
Okay.
Thank you so much, please. Yeah.
Okay, I'm ready to wait. So if that's possible, let's wait. Thank you. Okay, dear colleagues, then let's wait for 10 minutes. We will try to reach the professor.
Булат Нурланович,
Да-да.
could you please continue if he couldn't join today's meeting? Because
No.
without one member's quorum is
No,
okay,
no,
90%.
No, there are rules that all temporary members must be present.
So 100% should
Yes.
be joined, mandatory,
Yes.
right?
Yes.
Because as I know before my defense, several members doesn't join.
No,
That's
there
why
are
I'm
new
asking.
rules. New rules. Dear colleagues, I found your number. She will join now. Probably. Just a second.
Oh, thank you so much, Vladimir. Oof.
Okay, dear colleagues, I think Professor Rehab, she connected.
Yes, she's here.
Yeah. Dear Professor Rehab, could you switch on your camera just to confirm that you are here? Okay, dear Professor Ihab, can you hear us? Can you switch on the camera to confirm that you are here? Just because our colleagues want to make sure that you are present.
Hello, Assalamu alaikum. I am here. Please start.
Hello, thank you very much for connecting.
Yes, you're welcome. Please
Okay, dear
start.
colleagues, so we are ready, finally ready to start. I'm sorry for this delay. Probably there was some misunderstanding. Okay, thank you. And now we have all temporary members connected. Yeah, and we can continue. Please keep your camera on during the defense because we have broadcasted everything on YouTube and the defense is recorded. So now the floor is given to Scientific Secretary, Professor Tajibbayeva Sagdat Medirbekhovna, for presenting the documents available in the personal file of the applicant.
Thank you. Kanzhigitova Dana was born in 1997. In 2018, she graduated from Al-Farabi Kazakh National University with a degree of Bachelor in Techniques and Technologies. From 2018 to 2020, she pursued her master's degree in chemistry at the same university. From September 2020 to June 2023, Dana studied in the PG program at the Faculty of Chemistry and Chemical Technology at Al-Farabi, Kaznu. Her dissertation topic and scientific advisors were reapproved at the meeting of the Academic Council of Kaznu on March 6, 2024. Kanzhigitova Dana's personal file includes copies of her bachelor's and master diplomas, a list and the copies of her publications, positive reviews from the scientific supervisors, the protocol of the enlarged meeting, and all other documents in accordance with the regulations of the Committee for Quality Assurance in the field of Science and Higher Education of the Ministry of Science and Higher Education of the Republic of Kazakhstan. The main research results of her dissertation are presented in 3 articles published in Q1 journals indexed in the Web of Science and the Scopus databases. The first article is Advanced Materials with a percentile 99%. The second in Advanced Composites and the Hybrid Materials with a percentile of 98, and the third in Langmuir with a percentile 78%. On January 5, 2024, Kanzhigitova Dana's work was discussed at an enlarged meeting of the Department of Chemistry and Technology of Organic Substances, Natural Compounds, and Polymers. The meeting was attended by 39 people. The first reviewer was Elmira Nurgazieva, PhD, Senior Researcher at the National Laboratory Astana, Nazarbayev University. The second reviewer was Bates Malikovna Kudaibergenova, PhD, Professor of the Department of Chemistry and Technology of Organic Substances, Natural Compounds, and Polymers at Al-Farabi, Kaznu. Both reviews gave positive reviews. All questions and comments from the audience were addressed satisfactorily, and the scientific seminar anonymously recommended the work for defense. The defense date official reviewers and temporary members of the Dissertation Council were appointed on May 16, 2024, protocol number 5, at the meeting of the Dissertation Council. Thank you for attention.
Okay, thank you. Dear colleagues, do you have questions? to scientific secretary? If not, then the floor is given to the PhD candidate to report the content of the dissertation. The deadline is 20 minutes. Please.
Should I start?
Yes, please start.
Hello, everyone. Topic of my research is development of novel functional hybrid materials based on conducting polymers. So conducting polymers have been widely investigated due to their extraordinary advantages over the traditional materials, including wide and tunable electrical conductivity, facile production approach, and high mechanical stability. So recently, nanostructured materials studied for both fundamental research site and the potential application because of their unique properties at nano level. Here is the conductivity of conducting polymers are in the range of insulators and metallic conductors. If we make the tune the conducting polymer chain, we can make it metallic conductors. There are main types of conducting polymers is presented. Why ordered or nanostructured conducting polymers? Because if we ordered or nanostructured, they enhance the electrical conductivity, improved mechanical properties, optical properties, and enhance charge carrier mobility and high thermal stability. By increasing the orderly chain, we can increase charge transfer and increase conductivity respectively. So disadvantages of an irregular structures are lower electrical conductivity, lower thermal conductivity, less efficient charge carrier mobility, and tend to have less control over surface morphology. So there are numerous ways available for obtaining nanostructured conducting polymers, and the main ways is template-assisted method, self-assembly techniques, interfacial polymerization, solvent additive effects, and etc. So there are advantages and disadvantages of conducting polymer synthesis techniques. Here I marked in green used in this work. So inorganic template by continuous microemulsion and self-assembly techniques. So they have disadvantages. Advantages can result in highly ordered and uniform polymer structures, often leads to enhanced properties such as increased conductivity and stability. By continuous, they can produce a wide range of structures from 2D sheets to 3D nanostructures. So self-assembly technique, scalable and reproducible, allows for precise control over the polymer morphology. Problem statement: despite the promise of ordered conducting polymer chain for various electronic and optoelectronic applications, there is a need for new technique and new techniques. So there is a need for new strategies and techniques to obtain highly ordered conducting polymer chain with controlled morphology and alignment. Aim of research is to synthesize highly ordered conducting polymer chain with enhanced hydrogen gas sensing performance, advanced nanostructural morphologies, and improved electrical and mechanical properties using template-assisted method and self-assembly directed polymerization. Dissertation work is presented in the form of series of articles in accordance with the requirements of the Minister of Science and Education, Republic of Kazakhstan. So novelty of research is develop innovative methods to overcome the limitation provided by conventional synthesis techniques. And we offer two methods: by continuous microemulsion and self-assembly directed synthesis. Key objectives: investigate the impact of 4 different bicontinuous reactors, pure, non-ionic, cationic, and anionic interface. Design and produce 3D polypyrrole and their composites. Design synthesize composite of conducting polymers with vanadium pentoxide using intercalation and assembly method. Study the relationship between the structure, morphology, and the sensing properties of the fabricated materials. And last, synthesize aniline derivative monomer, polymerize this monomer using bicontinuous microemulsion system. The main provisions of dissertation work the highest conductivity is 219 times per centimeter, obtained for the nanosheet fabricated using bicontinuous microemulsion system. Then additional paratoluene sulfonic acid to vanadium pentoxide and polypyrrole made it possible to form ordered structure and of the composite, and method of obtaining various nanostructures of polyaniline derivative, nanospheres, nanorods, and nanoballs using bicontinuous microemulsion system made it possible to control their morphology. So why bicontinuous microemulsion system? Microemulsions are the self-aggregated system in which surfactant, oil, and water are mixed according with the proper proportion, usually in combination with co-surfactant. So investigation in microemulsion generally focus on the phase transition from the oil, water in oil to oil in water through the bicontinuous phase. In the right side, the image of atomic microscope in bicontinuous microemulsion is shown. We can see the continuous structure of bicontinuous system. So synthesis of first part, synthesis of aniline derivative monomer and design of polymerization using a bicontinuous microemulsion system. First step, the reaction step consists of three steps. In first step, acetic anhydride reacts with the amine group of 3-aminophenol to form an amide linkage, resulting in the formation of N3-hydroxyphenyl acetamide. This solution, acetamide, the first product, and potassium carbonate is reacted with dibromo-octane to form the acetamide compound. The acetamide compound is reflux with sodium hydroxide in ethanol to cleave the acetamide group to form the aniline derivative monomer, and obtained monomer polymerized using bicontinuous microemulsion system. They prove the formation of monomer proton and carbon NMR is shown, and the proof the formation. And after this obtained monomer, aniline derivative monomer were polymerized at the interface of bicontinuous nanoreactor, and their morphologies were controlled by changing the concentration of oxidant, pH, and the medium, pH medium and dopant, keeping the concentration of monomer constant. Polymerization aniline derivative monomer was further confirmed by FTIR spectra of the polymer with its monomer. Aniline derivative monomer has a primary amine group which can be seen at 3,400 and 3,300 reverse centimeter as a sharp doublet. In the polymer, there is only broad NH stretching. So aniline derivative monomer were polymerized at the interface of bicontinuous nanoreactors. As a result, obtained the different nanostructures. Here is to further control the morphology of aniline derivative polymers, paratoluene sulfonic acid is added, which can be served as both charge compensating and morphology controlling agent. Also, polymerization of aniline derivative monomers with changing pH also is observed, and the concentration of iron chloride and the paratoluene sulfonic acid was kept at 5 mg by milliliter. Results showed 4 different nanostructures of polyaniline derivative, including nanospheres, nanorods, and nanoballs. Formation of nanoballs via self-assembly of nanorods. Here is the mechanism. Nanorods are formed through the self-assembly polymerization of aniline derivative. These monomers self-assembled and undergo polymerization to form solid structures with a rod-like morphology. And the conditions during polymerization influence the growth and alignment of the nanorods, leading to their specific shape and size. And here, lattice fringe. From the lattice fringe image of nanorods, the distance between two aniline changes, two aniline distance was estimated to be 1 nanometers, which is close to the lattice distance shown in the transmission electron image. Each nanorod consists of approximately 65 units in length and 6 units in width. To prove the formation of both hollow and nanoball structures, we carried out disassembly of these structures at different pH levels. It was noticed that as the pH was 9 or larger, this nanostructure disassembled into nanorod structures. In acidic environment, these nanorods disrupted, and because of such pi stacking and hydrogen bonding are disrupted in acidic condition. So reorganization of the polymer chain into nanorod may be driven by the tendency of the polymer to adopt a more stable conformation or arrangement under the new pH conditions. AFM adhesion force measurement. To measure the adhesion force, the cantilever is driven by a piezoelectric actuator to approach the touched sample surface until the cantilever deflection. Then the piezoelectric actuator retracts to withdraw the cantilever from the sample surface until the probe sample bond is broken. Adhesion force is then measured as the probe sample interaction force as the breakout point. Here on the right side, AFM tip was modified with the silica because silica content is close to the glass surface, because our material is adhesive on the glass surface. That's why we spatter it with silica. So the surface charge of polymer was tested, was measured by AFM, atomic force microscope, and here the surface potential of film with topped with PTS is minus 150 millivolt. Other films plus charged. And the second part, paratoluene sulfonic acid topped vanadium pentoxide polypyrrole film for highly sensitive hydrogen gas. In this case, blending inorganic particles with organic materials is a strategy to enhance certain properties of single materials, such as mechanical strength, chemical stability via forming composite. Since here vanadium pentoxide has small lattice spacing, the direct intercalation of polypyrrole into the interlayer is not possible. To solve this issue, a simple assembly approach was developed to construct hybrid material. In this assembly, water force assembled into the vanadium pentoxide preliminary. So detection, our material can detect from 5 to 250 ppm hydrogen gas concentration, and quick response and recovery times is 42 and 37 seconds, and carrier mobility for the PTS topped composite is 14. Without PTS is 4.76. And increased carrier mobility allows for the free charge carriers to participate in the sensing process, leading to improved sensitivity. Morphology of the samples was investigated using scanning electron microscope and transmission electron microscope. In this case, the lattice spacing increased from the 16.2 angstrom to 17.3 angstrom, and also was confirmed by X-ray diffraction. XPS. So in this case, presence of N1S peak in both composite system, here D and E, proves the intercalation of pyrrole in vanadium oxide layers. In the composite system, intercalation of PTS decreased from B and C, decreased the vanadium vanadium 5 plus to vanadium 4 plus peak, and the vanadium 5 plus ions are susceptible to reduction to produce vanadium 4 plus ions. The N1S of polypyrrole composite tends to deconvolute into two peaks around 200 electron volt and 202 electron volt. Further doping increased the intensity and the peak area of the also it called polarant peak, and indicating that highly doping PTS results in higher conductivity volume. Sensor performance here to test the hypothesis, both films with and without topped PTS samples were tested to measure the hydrogen gas, and the fabricated polypyrrole films were tested at 5 to 250 ppm, as shown here. Without topped PTS samples show 7.88% response, and with PTS topped it shows 32.43%, which is the 4 times higher than not PTS doped samples. Response and recovery times of the two films under the gas was shown 43 and 37 seconds. So here also our material compared to other materials in this table, we can see it is pretty high. So third part, development of 2D and 3D conducting polymers and derived composites. In the synthesis of nanostructures conducting polymers interface, we can see plays a major driving force to manipulate the formation of conducting polymer nanostructures. So for this synthesis, we use different 4 different systems: non-ionic, cationic, anionic, and pure systems to produce different morphologies of conducting polymers. And we can tailor the morphology and properties of conducting polymer nanosheets using different reactors and control the electrical properties through interface nature, thickness, monomer oxidant ratio, and doping levels. So here, experimentally, we can see here monomer when excess or deficiency of monomer in the matrix leads to the formation of structural defects, or we can see nanopowders. So at low oxidant concentration, polypyrrole chain have a chance to grow in the bidimensional direction, since the nucleation sites are relatively low and the growth process over the nucleation process. Presence of so conductivity in this picture, we can see that in the D powder, the structure of polymer is powderish because counter ions SDS is negatively charged surfactant. The presence of negatively charged surfactant allow the 2D growth, does not allow the 2D growth of the polymer nanosheets. And the highest conductivity was 297 per centimeter, and was obtained with the DCM pure system without any surfactant. It is because of the there is no interfacial barrier and the easy transportation of doping agents. Design and synthesis of 3D conducting polymers. To design a 3D polypyrrole conducting polymer, special linkers were designed and mixed with the pyrrole monomer. So presence of the linker in the system has packing effect. We can see the from ECM image by increasing the concentration of linker in the reactor. This layered structure was packed and interconnected to form plate-like structures. Here is the possible illustration of 3D polymer. So 3D conducting polymer, and it's composite with carbon dot. We choose nitrogen doped carbon dot because this carbon dot has advantages in various applications. Synthesized polypyrrole carbon dot nanocomposite show outstanding iron 3+ ion detection capability. And by quenching and reactivation of carbon dot nanoparticles with ascorbic acid. And the polypyrrole carbon dot nanocomposite could be reactivated and with turning photoluminescence property. Proposed simple, efficient, and straightforward methodology can be utilized to design advanced functional materials. So conclusion, universal, easy, and scalable synthetic technique has been created for the design 2D, 3D conducting polymers. The conductivity obtained 2D nanosheet designed by a pure interface bicontinuous system, and unique high-performance hydrogen gas sensor has been successfully produced using PTS doping on hybrid film. At the same time, PTS can operate as a dopant in polymer film, reducing charge movement resistance to enable greater conductivity and hole mobility. PTS testing increased the response time and sensitivity 4 times. And a simple synthesis method was established for the fabrication of various conducting polymer nanostructures, as I showed, from hollow spheres to nanoball, 2D sheets, and arrays of nanoballs. So technology has the potential to have a significant influence on a variety of sectors, ranging from materials design to nanomedicine and energy application. 3 works were published in Advanced Materials, Advanced Composite Hybrid Materials, and ACS Langmuir. I want to thank Committee of Science, Minister of Science and Higher Education for providing grants, and our team, Renewable Energy Laboratory, under the Professor Nurshad Nuraje. First and foremost, I would like to express my deepest gratitude to my supervisor, Professor Nuraje, for his exceptional assistance throughout my research. Also, thanks to my Professor Rahmatullaeva, her support, insightful guidance, and profound knowledge. And I would like to also thank to Professor Adilov for helping with organic chemistry synthesis and insightful comments. And special thanks to Dr. Abu Talib. Her achievements and dedication have been a source of inspiration, and I'm really grateful to my best friend Perizat Askar, who has been my side throughout this journey, and to my all friends, family, and colleagues. Thank you for attention.
Thank you. Dear colleagues, what questions do you have?
Can I start?
Yes, Professor Hutoriansky, please.
Okay, thank you for your presentation. I have a couple of questions. First question will be about your work with gecko-inspired materials. So can you please explain what makes your materials gecko-inspired?
First, we observed that our material, our created films have the adhesiveness on the glass surface, and we characterized with other devices like AFM, and we checked the adhesiveness on glass surface, and it shows the good adhesiveness on silica. Then we claim that gecko, there are a lot of works with adhesive nature of gecko. So it is because gecko nails has the mushroom-like structures. Our films also here. Here with TM image transmission electron microscope, we can see the bubbles can be adhesive on the surface. So that's why gecko inspired.
And you believe that like this enhanced adhesiveness is due to this gecko inspired properties?
Yeah, because of the structure.
Okay, thank you. And how did you measure adhesion? And what was your substrate for adhesion?
We measured adhesion with atomic force microscope. Here we can see on the top scheme AFM. And why we sputtered AFM tip with silica, because the content of glass is mostly silica. Yes, that's why we covered the AFM tip with silica and then checked for adhesion.
So it's basically adhesion of your material to silica surface, right?
Yeah.
Okay, that's great. Thank you. And my final question, I think it is your slide 27, if I'm not wrong. You did demonstrate XRD spectra there.
XRD?
Yes.
No, we didn't check XRD. It is most amorphous structure.
Yeah, but then you had XRD spectra somewhere. I saw them.
Maybe this one?
Yes. And you said it's mostly amorphous structure, but in the beginning of your talk, I think you said something about that electric conductivity is due to crystallinity of your materials. So your samples are amorphous.
Yes, this is related to second part, vanadium pentoxide, this one, not related to first one, this one.
So these are different materials then?
Yeah.
Okay. Thank you.
Thank you.
Okay, dear colleagues, do you have other questions?
Can I ask?
Yes, Dr. Dergunov, please.
The first part, it's probably slide 14 or something. What was behind the structure? Why did you choose octalinker for creation of these anilines? And did you try shorter linker? What's happened if you will take shorter, and why did you choose this octa, like 8-member?
Thank you for your question. Yes, we of course checked with other carbon chain with 2, 4, 6, 8, and 10. But in 8 carbon case, we could obtain, we could polymerize our material in this bicontinuous reactor system. Maybe because of the maybe in 10 case it could be, how to say, scope structures or something like that.
It means that for the shorter linker, it's much more soluble and it's not forming the material in continuous layer?
Yes, in 10 carbon case, we could not dissolve this linker in solvent because of the polarity, I think.
Okay.
In future, in future, we are going to synthesize different structures and then polymerize with other systems, not this benzene, ethanol, and water system.
Okay. And about, I believe that about the same topic, probably next slide, about formation of this 3D objects of this formation of 3D objects from nanorods to spherical, or couple slides below, spherical, or then nanoballs. And that's happened because, this one. That's happened because of the property of these nanorods or supporting materials?
We believe that this is because of the self-assembly of, we called also this monomer polar amphiphile, because on both sides polar and between them non-polar, also polar amphiphile monomer. And this polar amphiphile monomer first self-assembly in the ethanol solution. Here we have in the system ethanol. Then polymerized using iron chloride, and with the pi-pi stacking and hydrophobic interaction, first polymer nanorods were obtained. Then we believe that these nanorods undergo created ball structures, and in here we prove that these balls created from nanorods. We disassembled it at different pH.
Yes, it is already polymerized materials, these nanorods, or it's just formed due to the interaction.
These nanorods, this nanorod itself is polymer. This polymer, this polymer by supramolecular interaction created ball-like structures. Also, here we did the experiment in by continuous microemulsion. Microemulsions are the surrounded by surfactants, and that's why different morphologies of conducting polymers we created, we believe.
Yeah, I understood this one. The slide number 16. You showed the first part is very, simple. You have monomer, then you have self-assembly and form stuff. Then you form nanorods. And then from that nanorods, you form 3D objects. And that's happened because of the property of nanorods itself, or you have some other materials that help to form that 3D objects.
Yes, I understand your question. In this case, we inserted paratoluene sulfonic acid. Here you can see this paratoluene sulfonic acid tend to create more aligned ordered structures, and in this case we also of course conducted with experiment with paratoluene sulfonic acid. Before the addition of paratoluene sulfonic acid, here on the left side we can see irregular shaped balls. With the addition of paratoluene sulfonic acid, we managed to control the shape of structures.
It means that even though it's the properties of nanorods themselves, and it means that without the supporting material like paratoluenic acid, they do not form 3D objects.
Yes.
Okay. And I did see that you mentioned about conductivity of 219, and this one is the largest number. What does it mean? Is it for just polypyrrole polymers, or for any polymers, or for any materials?
It's just with polypyrrole here. We polymerized polypyrrole only in the 4 different microemulsion system. Pure without surfactant, non-ionic. Non-ionic is with Triton X100 surfactant, and the cationic with cetyl methyl ammonium bromide CTAP surfactant, and the SDS is sodium diethyl sulfate surfactant. We carried out experiment, and there is only polypyrrole. Yeah. Here in this graph, with different reactor system with different surfactants, we did compare this conductivity, and the highest conductivity was obtained with non-ionic reactor system, and was 200. With DCM system 219 Siemens per centimeter, and with also non-ionic reactor system we could obtain 144 Siemens per centimeter.
Yes, but that number is because of the polypyrrole, or because of the system itself?
Because of the.
What about other, like in literature, usually for polypyrrole, what kind of numbers they have? Not for other polymers, for polypyrrole.
Polypyrrole. We reviewed other techniques, and there are less than 10 Siemens per centimeter. So of course there are several methods. They could obtain 1000 Siemens per centimeter with chemical vapor deposition, but this chemical vapor deposition is high cost and consumes a lot of energy. So in our case, we designed low cost and reproducible and high in large scale synthesis we offer.
Okay. Okay, thank you.
Thank you.
Thank you. Other
Yes.
questions?
Can I ask, please?
Yes,
Yes.
please, Professor Alamer.
Actually, I will ask the same question for the conductivity measurement. You get 219, I think not for polypyrrole because you use the dopant agent HCl. I think this is the secret, using the dopant agent. My question here, you make thin film and you measure the thickness 25 to 150 nanometer. How did you measure this thickness?
For the measuring thickness, we use profilometer. This profilometer, with the profilometer, we can check the thickness even in low quantities. Also for the measuring conductivity, we use 4-probe methods.
Other question, is it uniform film or non-uniform film?
In particular concentration, we obtained uniform film. With the excess of monomer or monomer deficiency case, we obtained only powderish films.
But you know, I read in the advanced material paper, I think this is not uniform film. When you measure the film thickness, did you get the average from different area?
Yes. We checked in different areas and compared.
How did you calculate the conductivity in detail, please? Now you have the film thickness. How did you calculate sigma?
We have the film thickness 1 divided by film thickness and multiply to ohmic resistivity of the sample. It gives us Siemens per centimeter conductivity. 1 divided by thickness and conductivity in ohmic.
Did you? I didn't understand yet. Did you use the relation R equal rho L divided by A?
I can show.
Did you use the relation R equal rho time L divided by A?
Surface area. Wait, I can show.
Yes, because you use, I think you make the film on the glass substrate. What is the area? I think it's effect. What is the area of the glass substrate? How did you calculate the electrical resistance? This is in the other word. How did you calculate R?
4-probe with 4-probe methods.
Using 4-probe method?
Yeah, here in this we can see Siemens per centimeter in bulk resistivity and sheet resistivity. In sheet resistivity, we have here ohm. 4-probe methods gives us ohm square and layer here in this multiply.
Excuse me, how did you get bulk resistivity? If we know the resistivity, you can find the conductivity immediately. Sigma equal 1 over R.
Our 4-probe method gives us the ohmic conductivity and by thickness.
Give us R. 4-probe method give us R. Okay.
Yeah.
I think you need L, the thickness, film thickness. You need the area. Then you can calculate rho. After that, you can calculate sigma. Did you make this or different way?
We did this way. We are saying in the same sentence. We use this equation.
Which equation?
This in this.
RS equal rho divided by T.
Yeah.
Could you explain the difference between RS and R? What is RS?
RS sheet resistance.
Okay. And when
R it's total resistance.
What about T?
T is thickness.
Okay, this means okay, from 4 probe, you calculate R. Then you calculate sheet resistance, isn't it?
Yes, yes.
How did you calculate sheet resistance from R? What is the relation between RS and R?
We check the conductivity directly.
What's the equipment to check the conductivity directly?
For probe method.
Excuse me, from four probe,
Yeah,
you can found R. After
Yeah.
that, you calculate RS equal RL divided by W. Then you can calculate rho from the equation RS is equal rho divided by T. Then you can calculate the conductivity. Okay?
Yeah.
Okay. Can I ask other question?
Yes.
Yeah, sure.
From XRD, you calculate D spacing. Okay? And also, I read from high resolution TEM, you calculate also D spacing.
Yeah.
And you find agreement between them. How did you calculate D spacing from high resolution TEM? You know the method. How did you for example, use software and that's it?
With just TM, not high resolution, we couldn't see the distance between two chain distance. With high resolution high resolution transmission electron microscope, we could see here. You can clearly see the distance, and it's just approximate data.
I think from figure C, and this is the important figure. Figure C, you can't see the plane between atoms. Okay. Okay. Next, did you use software to calculate the spacing?
Software. We just did plane and then calculate the between distance of this plane.
Do you know the equation to calculate the spacing? What is the name of the equation?
You mean XRD?
Yes, in XRD, what's the main equation?
Yes, in XRD, D equal alpha divided by 2 multiplied sinus theta. With this equation, we calculate.
Actually, there is famous equation. Do you know the famous equation to calculate the D spacing?
Yes. With this equation we calculated.
But Bragg law, you know Bragg law or no? Bragg law.
Yes. This with Bragg law.
And lambda equal?
Lambda equal D multiplied by 2 multiplied by sinus theta.
Sine theta. Excellent. Yeah. What is lambda in TAM? What is lambda in TAM? You use TAM and you use XRD. What is lambda in TAM? The wavelength of what?
Lambda is the XRD source in case...
No, excuse me. In TAM, not XRD source. In TEM.
TEM, yes.
Yes. What is lambda in TEM?
I didn't get your question, sorry.
You use 2 methods to calculate the spacing. You use XRD and you use high resolution TAM.
Yes.
Okay. And for all methods, we use Bragg law. Bragg law in lambda equal to D sine theta.
Yes.
What is the difference between lambda in first method and second method?
About TM, I didn't check by myself. My colleague checked the TM for me. I just did XRD and calculated the D spacing.
Excellent. Okay. For EDS analysis, you find vanadium, oxygen, carbon, sulfur, and nitrogen.
Yes.
Okay. We miss one element hydrogen.
Hydrogen.
Do you know why?
There
Do
is
you
a
know
reason.
why? Where is the hydrogen?
I forgot the reason, but I think there is a reason.
There is hydrogen, but where is in the spectra? There is no hydrogen. Do you know why there is no hydrogen?
Could you please explain why there is no hydrogen?
Because ADS did not detect hydrogen. That's it.
Okay. Thank you. Why?
Can I go to other question?
Okay.
You calculate the mobility. This is you find the important result.
Yes. Detailed slide again, yeah.
Okay.
Yes.
Could you explain to me how did you calculate the mobility in detail? How did you calculate? This is important result.
This is direct data. We calculate. We picked up same sheet shape. And
you use Hall effect device, isn't it?
Sorry.
To calculate the mobility, you used Hall effect device.
Yes, Hall effect measurement we did.
Yes, explain to me how did you calculate the mobility in detail?
This is our computer system gives us the direct data, and we just use this data to make decisions or to make.
No, I don't think so. The computer gives the value of mobility. Do you know the relation between the conductivity and mobility?
Yes, this device gives us bulk concentration, sheet concentration, and the mobility data from direct.
My question, what is the relation between conductivity and mobility?
Conductivity equal concentration, bulk sheet concentration, and mobility.
Sigma equal in Q mu.
Yes.
And the concentration, okay?
Yeah, concentration and mobility.
And also you in the manuscript, you write, we calculate the mobility and the concentration, but I didn't find the value of the concentration.
Because our purpose is to increase hydrogen gas.
No, my question, you wrote in the manuscript, you calculate the mobility and the concentration, but you can't find the value of the mobility. Where is the concentration?
Yeah, we didn't show the concentration.
Can you ask you, I also, is it, what is the type of the charge carrier in this system?
What is
the type of the charge carrier? You do polypyrrole by using HCl. What is the charge carrier? Is it Hall or electron?
This is Hall. Hall.
Excellent.
Yeah.
Is it Hall? Excellent. How do you know? Is it's Hall from Hall device equipment? Is it any way to discover this is Hall charge carrier from Hall device measurement?
From the structure of polypyrrole, it's obvious it's Hall conductor. Hall gives
I want to know from Hall effect device.
Hall effect device?
Yes. You know there is something called Hall coefficient, RH. If it's positive, this means this is Hall. It's negative, this means electron. Thank you so much. Thank you so much.
So is this positive?
Yes, it's positive. Thank you.
Yes.
Thank you.
Thank you. Dear colleagues, do you have other questions? Okay, I have a couple of questions about the provisions for the defense. So you have 3 provisions, you call it rules in the abstract. Okay, you say about the second provision, that the addition of PTS to vanadium pentoxide and polypyrrole made it possible to form another structure of composites and increase the mobility of charge carriers from 4.76 to 14. Okay?
Yes. Yes.
What are the uncertainties or errors of these two values, 4.76 and 14? What are the standard deviations or errors or uncertainties?
You mean reproducibility? Yes.
Yes. Did you repeat this experiment?
Yes. We repeated several times and they made the average.
So these are the average numbers.
Yes. Yes.
Yeah, but
We
what are the values of standard deviations?
No.
Why don't you report them, the standard deviations? They are not important or any other?
Yes, they are important. We just did several times and made average value.
Okay, but what was the
Yeah,
value
we should
of standard
have.
deviation?
Yeah, we should have calculated standard deviation.
Okay, but for example, how many measurements did you get for this 4.76?
5.
5 measurements, okay, and
Yeah,
what are
5
these
measurements.
values, plus minus?
Plus minus 4, 4 point, if I'm not mistaken, 4.4 to 5.
Okay. Okay. And you say that the hydrogen gas response increased.
Yes.
What are because in the, okay, what do you mean by the percentage?
Percentage
So
was
how did you measure this response?
percentage was calculated from this equation on the right.
Okay. But did you get any standard deviations again for these values?
There is also, we did several times, but did not calculate, yes, standard deviation.
Okay. Okay, and let's go to the first provision. Okay, you see that the highest conductivity is obtained for the nanosheet fabricated using a clean interface reactor system. And then you write it was due to the absence of interfacial barrier and easy transport of dopants. Can you prove it that it was due to the absence of this barrier? Do you have any evidence for this statement, for this reason? Can you prove it somehow, or it's just a guess?
Yeah, we did comparison from other literature review, and but there are no literature review based on microemulsion. They didn't use microemulsion system to polymerize the monomer. It's our guess because in the pure interface we don't have any surfactant to make them to make interfacial barrier, and it's our guess, yeah.
Okay, but this is the in these provisions for the defense, there should not be some guess. This is something you have to prove to us.
Yes, we did with other surfactant systems with non-ionic, anionic, and cationic surfactant with the presence of other surfactant, and we have conductivity data to make sure.
Okay, thank you.
Thank you.
Dear colleagues, do you have other questions?
I have one. Okay, it's okay.
Yes.
Okay,
Keep going.
Professor Rehab, you have questions? Professor Rehab?
Yes, hi.
Hello.
I want to ask the students about the material you are prepared. You are needed if you do any composites XRD techniques for justification how this modification affected on the crystallinity of the prepared material. Are you performed XRD for all material or composites you performed?
You mean
XRD
part?
analysis.
Yes,
XRD
yes.
analysis.
Which part are you asking?
Vanadium modification, carbon dot one.
Carbon dot one. No, we did not do
Why?
XRD. You know, conducting polymer is just overall amorphous. From just X-ray diffraction, we cannot see the crystallinity.
But sometimes I already published about polyanilenes when you synthesized synthetic clay with polyaniline as a composites. The crystallinity of polyaniline enhanced very good, and XRD actually different about the polyaniline itself. Okay, so I suggested that in the future work you must need it to make XRD because it is very cheap technique. Okay.
Yes.
Okay. Another questions. I think all study about the census. What about the economic estimation of cost in your research?
We did not calculate economic value because I'm not how to say engineering student. I'm just chemist, fundamental chemist.
I advise you that you need it nowadays to make this estimation and also comparative your material by other to be performed in large scale. Okay. Also, another questions. What about the estimation of stability of your prepared material? You estimated the stability analysis for your synthesized material or not?
We didn't check the stability. In the future, we are going to study this. Thank you.
Another questions for you also. What about your future prospect for your thesis and your research work? Because your material, I like it very much because as I already work in medical application and the energy application and water treatment field, and your synthesized material in my goal. So it's very important to think about what about your future prospect about this material.
Thank you. Now, currently, I am synthesizing self-topped conducting polymers, self-topped. And the second work, I'm doing this hollow and bowl type conducting polymer shapes with future using this material for drug delivery or other biomedical
energy application. It's a very good material.
Thank you.
Thank you so much. Thank you.
Thank you.
Thank you. Thank you. Dear colleagues, anybody, somebody had the question?
Yeah, I have one.
Okay, please.
It's about your first part when you were measuring surface charge by Kelvin probe microscopy. I think it's slide 17, maybe.
This one?
Yeah. I'm not familiar with this method. Maybe you can just comment on that. How actually the experiment was done, and how did you get these numbers? And there is another question related to the what was stated before about the uncertainties, experimental errors. So your surface potential is minus 150 plus 200. What is actually, what was the experimental uncertainty for this Kelvin probe force microscopy experiments? How it was performed?
Thank you. Actually, I didn't do this experiment by myself. I just did all this material with different shapes and modulation of these shapes. And this part was done by physics. And they just provide me datas.
Okay,
Yeah.
thanks.
Thank you.
Thank you. Okay, dear colleagues, any other questions? Okay, if not, then we continue to the next step.
Can I have one more question, please?
Yes, please.
Just one more question.
Please, Professor Alamer.
When you use, I think when she measured the electrical conductivity, she used sulfur-based and the
Yes.
polyvinyl film.
Yes, yes.
Make electrical contact, isn't it?
Yes, yes, right.
You know, my concern when you use sulfur-based, sometimes the sulfur diffuse in the film. The sulfur particle diffuse in the film, and maybe this will increase the conductivity. I suggest in your future work, instead of use sulfur-based, I suggest to use copper tape. This is my suggestion. This is in the future work.
Copper tape?
Copper tape.
Oh, okay, okay.
Instead of sulfur, because sometimes sulfur diffuse and give high electrical conductivity.
Okay. Thank you.
Thank you. It's a suggestion. Thank you.
Okay, thank you.
And probably I will add a little bit. I think it's about second part. Technically, it's stock of 2D materials. I think SEM about this. Yeah, maybe this one. It's stock of 2D materials, not like real 3D materials. And did you measure amount of layers and how that amount of layers affect conductivity of the materials? Is it, and again, about this penetration, can it be like penetrates to the upper layer and then like in between layers will be not affected by penetration of this other stuff?
You mean silver paste or other contact material?
Yes. My question is amount of layer, is it effect on conductivity? Did you try to
in this research,
estimate?
Yes, we didn't consider the porosity. We didn't conducted BET measurement, porosity measurement with the PTS addition. In the B picture, this film was swollen a little bit, and I think that's why when hydrogen absorbed onto the surface, swelling, it could also affect the sensitivity.
Okay, thank you. Dear colleagues, other questions? If not, then the floor is given to scientific supervisors. So the local scientific supervisors, Dr. Rahmetullayeva and Dr. Nuradja. So please, the floor is yours.
Siz soruyorsunuz var birinci.
Yes, you can start. Можете начать.
Nusrat Ağay, өзіңіз бастаңыз.
Oh, sorry. Can you hear me now?
Yes?
Yes, great. Okay, I think this. I want to thank the reviewers. Very nice comments, very suggestions, a lot of very thoughtful questions. Actually, Dana was after her one semester study in National Al Farabi University, moved to my lab. She's working very hard. We start this project with like bi-continuous technique to like nanoreactor to make different type of nanostructures conducting polymer. And then she start to opening up this area. And then she bring up like a new two papers. One is making vanadium oxide as a conducting polymer application for like a sensing, hydrogen sensing. Like hydrogen sensing also a very important area. She explained, she developed like intercalation, like self-assembly technique to make this kind of composite material. Actually, this all of the work done by herself. She proposed this idea, I accepted, and then she proved. So this is amazing. And the second is also, we trying to design like nano conductive polymer linkers. We trying to create 3D. In this case, she synthesized all of the like linkers and then start to finding out different type of nanostructures, like a hollow sphere to like a self-assembled nanorod, nanoballs, we call nanoballs. This amazing nanostructure she found it. And then, so that's the reason she's the first author. She published the two papers, Langmuir and Advanced Composite Hybrid Materials. So her work is amazing. So here's I couldn't say anything. So she also discovered this mechanism, how like a nanorod assembled. She proved actually how to nanorod form nanoball. And then she also explained, especially like intercalation method, like inserting conducting polymer between like a vanadium oxide, these layers, creating very like a intercalate structure, not only intercalate, this layered conducting polymer improve conductivity. And then she explained how improve like sensitivity. So far, I think the 5 ppm like detection of hydrogen concentration. This I think is a world record, I can say, so far. So I am very proud of have this kind of student, Dana, in my lab. So I don't have other comments besides complimentary. So I am done. So thank you for
Thank
giving me
you.
to speak.
Thank you. Dear colleagues, do you have questions to Professor Nuradja?
I am happy to defend.
Thank you. Рахат Кулымбетовна, пожалуйста.
Саламатсыздар ма, құрметті әріптестер, диссертация мүшелері. Бүгін міне осындай уақыттарыңызды бөліп, жұмысты тыңдағандарыңызға рахмет, сұрақтарыңызға рахмет, өте жаңағыдай орынды сұрақтар қойылып жатыр. Енді жаңа профессор Нұршат Нұраджи жұмыс жайлы айтса, мен енді Дана бойынша айтып кетейін. Дана енді тақырып о баста цитириондармен байланысты болған, менің алғашқы докторантым Әбутәліп Мінзияның жұмысының жалғасы логикалық болған, бірақ та пандемияға байланысты Назарбаев университетіне стажировкадан өту керек болды, Германияға жіберілмеді ол кезде. Сөйтіп осы профессор Нұршат Нұраджидің зертханасына барып Дана жұмысын бастады. Әрине Данада цитринион бойынша да, осы жаңағы өткізгіш полимерлер бойынша да жұмыстар өте көп болды. Сол Назарбаев университетіне стажировка барғаннан бастап осы өткізгіш полимерлермен айналысып, сол бойынша міне жұмыстың өте ауқымды, жақсы екені, осы мақалалардың куберге шыққан жаңағы несі инфофакторы жоғары журналдарға шыққаны дәлел бола алады деп ойлаймын. Енді Данаға келетін болсақ, Дана әрине неорганика кафедрасын бакалавр магистратурада да бітіріп келсе де, биорганикалық химияны, полимерлер туралы теориялық білімін осы зертханада көптеген жаңағы приборларда жұмыс істеу арқылы өзін жетікті, жаңағыдай өте дамыған ғалым ретінде бүгін міне өзін көрсете білді. Қаншама осы 2,5 жыл жасаған жұмысын міне бүгін өте ашып көрсетті деп ойлаймын. Осыған байланысты докторлық диссертацияны орындау барысында Дана көптеген заманауи жабдықтармен, приборлармен танысып, соларды егжей-тегжейлі жұмыс істей білді. Сондықтан да енді осыған байланысты жаңағы профессор Нураджидің жаңағы зертхана тобына, әсіресе менің өзімнің алғашқы докторантым Абутәліп Мінзияға, сондай-ақ Адилов Сәлімгер ағайға рахметімді айтқым келеді. Сіздерге өте көп рахмет. Сұрақтарыңыз өте орынды болды. Өте жаңағы жоғары деңгейде өтуді жадым. Енді өздеріңіз әділ бағаларын бере жатарсыздар. Рахмет.
Рахмет, thank you. Okay, and now the floor is given to the foreign scientific supervisor, Matthias Ulbricht. Is Professor Ulbricht here? I don't see.
She couldn't attend the
Okay,
meeting
then
because
if not, then scientific secretary Professor Tajibbayeva will read the review of the foreign scientific supervisor.
University Duisburg, Essen. Dear members of the committee, it's my pleasure to provide a review of Dana Kanzhigitova's dissertation work, which is presented as a series of articles. Her first paper, Strategic Synthesis of 2D and 3D Conducting Polymers and Derived Nanocomposites, was published in Advanced Materials. This study investigated how four different biocontinuous microemulsion systems affected the shape of a conducting polymer. The systematic use of a biocontinuous microemulsion system without and with different surfactants allows for the preparation of conducting polymers nanocomposites in a controlled environment, allowing for fine manipulation of the material's characteristics and design. The system connected oil and water phases create a large interfaces area, allowing for effective mass transfer and interactions between the components, resulting in increased electrical conductivity. The system with the highest conductivity had a value 219 Siemens per centimeter, much higher than for previously reported similar to D materials. The article is well written and informative about the synthesis and prospective applications of conducting polymer nanocomposites. In her second research published in Advanced Composites and Hybrid Materials, Dana Kanzhigitova studies the charge transfer properties of the resulting electrically conductive polymers to explain the composites' beta hydrogen gas sensing properties. To improve sensing performance, the carrier mobility and concentration, as well as the arranged structures of polymer chains, were investigated. The study provides insight into the fabrication of highly sensitive hydrogen sensors based on a hybrid thin film of vanadium pentoxide and polypyrrole. The findings of the study have important implications for the development of gas sensing systems for a wide range of industrial and environmental applications. Her third paper, Controlled Synthesis of Polyaniline-based nanomaterials with self-assembly and interface manipulation, which was recently published in Langmuir, reports on the controlled synthesis of polyaniline-based nanomaterials by self-assembly and interface manipulation methods. The authors emphasize the unique qualities of conducting polymer nanostructures, such as their electrical, optical, and thermal properties, and describe their potential uses in a variety of applications, including medicine, energy storage, and adhesive materials. Overall, the research of Dana Kanzhigitova has made original and relevant contributions to material science and engineering, and provides a profound basis for a doctoral dissertation. Professor Dr. Matthias Ulbricht.
Okay, thank you, Professor Tajibbayeva. Do you have questions? to scientific secretary? Okay, if there are no questions, then the floor is given to the first official reviewer, Azad Seidkhan from Satbayev University. There is no need to read the review. Just we will share the screen with the review. Just tell the most important like conclusions of your review.
Okay, yeah.
Mhm.
Can I start?
Yes, you can start. I will
Yeah,
just
okay.
share the
Thank
screen.
you. Thank you. Good afternoon, dear colleague. Here, the head of this dissertation council and the member of this dissertation council. So, my review to the dissertation of title of the dissertation, development of novel functional hybrid material based on conducting polymers. The point one, the dissertation work was performed the several projects funding from this Nazarbayev University funding. So there's from this demonstration you can see some list of these projects. So the work makes the significant contribution to science, and it's important is well dissolved the problems. So we can say this all results from this several the very important articles, the results, the three articles, materials today, the Langmuir, some the all important results. Yeah. So the point three, this the level it's a bit higher. The 4.1. The justification of the relevance of the thesis. This yes, also the point one just justified. The 4.2. The content of the thesis reflects of the topic of the thesis. Yes, it reflects. And 4.3. The purpose and objectives correspond to the topic of the thesis. Yes, correspond. And the 4.4, all sections and the provisions of the thesis are logically, completely interconnected. So 4.5, the new solutions, principles, methods proposed by the author are reasoned and evaluated in the comparison with this known solution. Yes, first, there is a critical analysis. So for 5.1 are the scientific results and the provisions new. Yes, I suggested there's completely new experiments. Yes, it is the all the novelty of this work suggested by this several high level the articles. So 5.2 are the dissertation findings new. Yes, so I suggested completely new. 5.3 technological economics or the management. Here, yes, I also suggested this the completely new. The point, the characteristics, yes, our main conclusions based on the well-grounded for, the overall findings confirm that the conclusions are significantly significant and supported by the substantial evidence. So the it is necessary to ensure the following questions. So the 7.1, yes, first proven. Second, the 7.2, is it trivial? No. And the 7.3, is it new? Yes. 7.4, application level. Yeah, I suggest that very widely the application this work, because I hope the member of the dissertation council has also suggested some widely the application level. So 7.5, is it proven in the article? Yes. The provision 2, the 7.1. I'm sorry, it's completely provision 2. So there in the criteria 7, I have some of this notes. So the first one, the needed some more detailed explanations or the discussions regarding the mechanisms behind the observed changes in carrier mobility and the sensor performance should be provided. I think it's just my recommendation for the maybe the future the works. And the 8.1, the choice of the methodology justified for the methodology is described the sufficient details. Yes, general observation, the ability of the manipulate the morphology and the shape of the conducting polymer nanostructures of the create adhesive film structure demonstrates high level of the creativity and the technical expertise. And the 8.2, my answer is yes, because it is the dissertation work provided results through using a modern scientific research methods and extensive characterization approaches. We know that Nazarbayev University have this very good facility and the modern techniques and equipment. So in this work, the widely used this modern equipments, it's including the XPS, the NMR, XRD, DSCA, TJ, SCM, TEM, others. So 8.3, also my the ensure it is a yes, theoretical conclusions, models in the identify some 8.3 also yes, and the 8.4 important statements are confirmed. Yes, the findings of the study match with the previously published research, accurate citations of relevant sources are included. So 8.5 also sufficient. The main findings in the study are supported by the citation from current and the relevant scientific literature. Each of the three research improves on the current knowledge and the methodology using recent and reliable sources of support the innovative approaches and discoveries. And the 9.1, the thesis has theoretical value. My answer is yes. 9.2, the thesis is practical importance and there is a higher probability of applying the results obtained in the practice. Yes. 9.3, as a practice suggestions new. Yes, completely new. Suggestions are new. So academic writing quality, I like the academic writing style. I suggest it's very high academic writing style. The work is writing using the scientific and the technical language, and the research method is properly explained. So my suggestion is to award the degree of the Doctor of Philosophy or the Doctor of Specialization. The dissertation work shows scientific knowledge through its explanation of the results, discussion, and the conclusion. Dana Kanzhigitova has developed expertise in the synthesis and application of polymers, making the qualification highly relevant for the driving forward progress in our country's scientific area. I highly recognize her work and strongly suggest awarding her Doctor of Philosophy degree in the field of chemistry. Thank you.
Thank you. So the floor is given to the PhD candidate, Dana Kanzhigitova, to respond to the comments of the official reviewer. Microphone.
Or it's necessary to provide clear explanation for the selection particular in the in the techniques. First, in the presentation, I clearly show why I showed by continuous microemulsion technique. There are several advantages, like we can control the polymer shape with different shape, and it's easy, scalable, and cost-effective method. Clear recommendation for future research direction based on the findings of this study should be provided. Thank you for your recommendation. Yes, each article, it's mostly fundamental research. In the future, we are going to do application part more clearly and more how to say profoundly. And in the first part, our obtained nanostructures we are going to use as drug delivery or other biomedical applications. Third, more detailed explanation or discussion regarding the mechanism behind the observed changes in carrier mobility and sensor performance should be provided. By the increasing of carrier mobility in our case is holes in the conducting polymer. When inducing the paratoluene sulfonic acid, we could rearrange the polymer chain, and that's why carrier mobility increased. And also by this, sensor performance also increased respectively.
Okay, Dr. Azad, are you satisfied with the response?
Yes, sure. Thank you.
Okay, thank you. Okay, dear colleagues, do you have questions to the first official reviewer? Okay, if not, the floor is given to the second official reviewer, Dr. Haysaf Chukir. So please, the floor is yours.
Good evening, dear colleagues and dissertant. Let me say some words in Kazakh. After that, I will ask my questions in English.
Okay.
Презентацияны тыңдау барысында диссертанттың өзінің бағытын жақсы түсінетінін білдім. Полимерлер химиясын, тағы басқаны жұмысын қолдаймын. Менің сұрақтарым көбінесе электрохимияға байланысты, сол себепті дұрыс қабылдауларыңызды түсінемін.
Қазақша айтпай?
Так, let me ask some questions. About first provision, and I would like to say that your data should be reproducible, and you should show all conditions in the provision. For example, here you say that the specific conductivity is 219, but it depends on temperature and other factors. The provision should be clear. And in the article, I couldn't find some details. How was this conductivity was measured, and about equipment, and what is the surface area of your material and thickness of your material. And the first question is about influence of environment condition. For example, your material can absorb water from the air, and it can be affect to the conductivity. Also, second question, also about influence of different factors to the conductivity. And last question is about benefits of your method. For example, comparing with electrochemical method. In your presentation, I saw in the table the benefits of your method and electrochemical method, comparison of different methods, and I think I have got the answer to this question. About second provision, first question is about the operation, principles of operation of your sensor. Is it pure physical sensor or partially electrochemical sensor? Because signal, it is not clear. Is your signal current or resistance? And I also couldn't find from the articles part about measurement of the electrochemical conductivity and this part. For example, what is the signal and the amplitude or frequency of your signal, or nature of your signal? Is it constant current or alternating current? It's important because for checking the reproducibility of this data, we should know all details about the measurement. And can this data, I think this data should consist standard deviation, or you should show influence of all factors to your data. That's all. Thank you for your attention.
Okay, thank you. And what is your recommendation?
I support this work, and my recommendation is to give PhD degree to the dissertant.
Okay, thank you. So now the floor is given to Dana Kanzhigitova to respond to the reviewers' comments.
Thank you for your comments. Specific procedure and methods for measuring electrical conductivity are not detailed in the article. We wrote that we used four-prof methods to measure conductivity. In most articles, they did not consider the specific conditions. It's how to say, it's a common procedure. We can just did contact with metal and then measure the conductivity. Second, ACM image. About a humidity test, you mean, yeah? We didn't do the humidity test. Our aim was to detect hydrogen under nitrogen atmosphere. In the future, we are considering to do this part, humidity test part. Currently, we are doing this part, and we'll publish to other article. Polyaniline is a well-studied conducting polymer. What is the advantages of the method proposed? Yes, polyaniline is well-studied polymer, but there is no nanostructures of polyaniline, like conduct electricity and different shapes of polyaniline. So our method can create different shapes of polyaniline structures and tune their properties. Second provision. It is chemical sensor. It's not physical or electrochemical. In physical sensor, it measures the physical force, like piezo effect or other forces. Our sensor is chemosensor. Experimental section lacks of information on the surface area of the electrode or composite material, making it difficult to understanding the relation between signal and the active material. I didn't get a second comment.
Surface area. So there is missing information on the surface area.
Surface area of which part?
Of the electrode or composite material.
In the
Did you
second
measure
part.
it?
Yeah, I already answered. We didn't measure the surface area. We measured only the impact of doping, paratoluene sulfonic acid doping on the structure of material. Measurement procedure is not specified, including whether the signal is constant, alternating its frequency. This is DC direct DC current. Applied voltage was 0.01 millivolt. Even when we increase the voltage, the polymer could not show any response because because it's polymer, not metal or metal oxide. We just need very small voltage.
Okay, thank you. Dr. Avchukir, are you satisfied with the response? Would you want to add anything?
Thank you for answers. I have to say that electrochemistry is also chemistry. If your
Yes.
answer is
I am
chemical
not master.
impulse chemical parts.
Yeah.
Thank you.
Thank you.
Okay, thank you. Dear colleagues, do you have questions to the second official reviewer? Okay, if not, then let's move to the discussion. So now, please comment on the correspondence of the dissertation to the principles of independence, internal unity, scientific novelty, reliability, and practical value. Yeah, and please do not tell how you will vote because the poll is the secret. Yeah, so please comment only on these principles. Okay, so who wants to speak? There were a lot of questions, so I think there can be an interesting discussion. I'm particularly interested in the opinions of the temporary members of the dissertation council because you were invited as the experts in this direction. Yeah, and your opinion is very important for other members of the dissertation council. Yeah, so please comment. We have 4 temporary members. So Professor Alamer, maybe you want to speak? You had a lot of questions.
Actually, I would like to commend Miss Dana for outstanding work she has done in her PhD dissertation. Actually, she has published 3 excellent papers in high-level journal, which clearly demonstrates the quality and significance of her research. I think she did a great job.
Okay, thank you.
Thank you.
Okay, Dr. Dergunov, maybe you can tell a couple of words.
Yes. I think it was so many questions because I believe it's very interesting topic, and but again, for presenting, it is better to compare with something already known, and if you claim that you have that huge value for example, for conductivity because of what? Because of the nanosheets, because of the material, because of the other stuff. But that is organizing stuff. But other than that, yeah, I think it's well done work, and it looks like the PhD candidate understands what she's done, why she did it, and how it will be applied. But yeah, other than that, I think it's a good job.
Okay, thank you. Dr. Filipov?
Well, I actually agree with two previous opinions. I think it's a solid work, and PhD candidate answered on all our questions. So I have no doubt that it's a great job. Yeah, so I fully agree with the previous comments.
Okay, thank you. The Professor Mahmoud, do you want to say a couple of words?
Yes.
Please.
Yes, I'm with you. Actually, I agree with Azar. The scope of the research is very good, and the student understands all topics. She needed some modification to her job to be more sounded, but I am agree she is doing well, and I suggest her to take care for all points suggested by all scientists present here. Thanks.
Okay, thank you. Thank you. Dear colleagues, do you want to add anything? Okay, then maybe I add a couple of words. So the research is very good. So there are good publications. Yeah, but the major drawback, unfortunately, is the lack of the measurements quality. So the standard deviations not reported. I don't know how reviewers of the articles checked that, because there are a lot of measurements, a lot of uncertainties, especially in this such surfaces with a lot of roughness. Yeah, some of them are uniform, but some of them are not. There will be always a variation, and this standard deviations are very important when making conclusions, when comparing the statistical significance of the differences. Yeah, so I hope this like comment will be considered in the future research. Yeah, because it's very important. So quality of research is very important, and to make sure the results are reproducible, you have to report with standard deviations, definitely, because then some other researchers cannot reproduce your results with to get such accurate numbers. Okay. So now I will give the word to Dana Kanzhigitova, the last word for today's defense, please.
Thank you all to hearing my PhD defense presentation, for commenting. Especially thank you for Professor Alamer for fundamental questions, and some of them I didn't answer, some of them did. I will consider all these questions in the future, but still we are doing on the process. We have a lot of works, and thank you for all to hearing my defense and being with me, and thank you Professor Noshat Naraje for providing conditions, work condition, and giving advices. Thank you for all, and who is not mentioned, thank you to all persons who is attending my PhD defense.
Okay, thank you. So, and now we move to the secret poll that will be conducted here in Zoom. Yes, so all members of the council and official reviewers must vote. For other defense participants, the break is announced. Yes, so we will move you to the waiting room. Please do not disconnect. We will get you back after the secret poll is ended. Okay? So please do not disconnect, and I will. It will take a couple of minutes for me. Okay, we have only the members left in the room. I will connect from my another account because I cannot vote from the main account because I am the conference organizer and I cannot vote. So just a second, I will connect. Okay, this is me. So now we have 9 people to vote. So now you will see on your screen the poll. Just a second, I will start it. And you will have to vote for one of the decisions. Vote only once. So we have one vote left. Okay, that's all. So just a second, I need to save it. Okay, we finished, and now I will invite everybody to show the results. Just a second. Okay, I see that everybody returned. You see PhD candidate. Okay, Dear colleagues, we finished the secret poll, and I am ready to announce the results. So now you will see them on the screen. Okay. So according to the results of the secret poll, we have 9 votes for awarding the PhD degree. Yeah, so and no votes for other decisions of the dissertation council. Do you see the results? Are there any questions to the results and to the secret poll?
No.
Okay, thank you. So then I close everything.
Congratulations for Dana.
Just a second. Just a second. So, and now I'm ready to announce the decision of the council. Okay, so based on today's defense and the results of the secret poll, so our dissertation council makes a decision to award the PhD degree to Dana Kanzhigitova on the educational program chemistry. So my congratulations to Dana and actually Dr. Dana Kanzhigitova, and thanks to everybody for this defense, and congratulations to everybody for a great defense. Thank you very much, and I wish you success in all your research
Thank
and
you.
future career.
Congratulations.
Thank you.
Yeah, also my congratulations. So good.
Congratulations. Good job.
Thank you.
Congratulations for Dr. Dana.
Yeah,
Thank you.
congratulations.
Mhm.
Congratulations.